Alright guys, so this is going to be a tutorial of making a 4-bar mechanism in Simscape. I'm going to build the 4-bar mechanism that is in Lecture Notes 3 if you're looking for the parameters for it. So we will start off here by defining all of our variables under the untitled one that you happen to be working on. Model workspace, I am going to use MATLAB code for my variables, and I'm just going to enter in all the parameters that I need with the units associated with them. Alright, so for this one, I believe that that is all the parameters that we need to specify. So now even though the reinitialize from source is grayed out, if you just click on it, it'll come to life, and tap it again, and you'll see your variables come into your workspace over here. Now that we can close out of that, so starting with the standard smnew package that it brings up, I am going to start by actually making the first bar, which I believe on there is A, which we will call, this is going to be bar 2. So I'm going to move these over, get another rigid transformation out here, just by typing anywhere in the workspace. I'm going to connect everything. So I also just remembered that I want to define a thickness here, which will be T 0.05. So we'll see how that is. Reinitialize from source. I should see my T over there. I do. Alright. So I'm going to start with this solid here. We are going to do a brick, and it is going to be ATT, so it'll be square cross sections and however long A was, a meter or so. And then in graphic, I'm going to change the color so that I can see what's going on when I build this thing. And then hit F5 and it should show me a brick. And if I click on this button over here, it'll show me a reference frame that is connected to R on the block. You can see that the red axis is X, green axis is Y, blue axis is Z. So that's how the axes are oriented on the brick when it's extruded. Now, I'd like to show the reference frames here. So I'm going to get rid of this just for demonstration purposes. We'll connect this to the world frame. So now, if we update our diagram, switch to the top view, we are doing something weird here. Maybe I didn't hit apply or something. So ATT blue. Okay, so we do have that now. Okay, so whatever that was, I wonder if it was a different one. No, okay. So if we look at this, we have this rigid transform here, which let me rename this. This is going to be example 1, just so we can find it. Update that. So now we can see the solid. This is, if you click on this, this has the reference frame here that is native to the solid. And then this is our example reference frame, which as you can see is directly on top of it. It's coincident with it. So I would like to demonstrate the different axes here. So if we go in here and we translate using a standard axis, we're going to translate up to positive x-axis. A over 2. This will put us down here at this end because the base here is connected to our reference frame in the middle of the brick. So now it puts it over there. Now, if I were to connect this the other way, still translating in the positive x direction, A over 2 units. Puts the frame on the other side. So that's something to get familiar with, is if you're on the follower, you're going to be translating down sort of the negative of whatever axis you select there. So that was just a demonstration of that. Now we'll continue here making our 4-bar mechanism. Connect all these together. Make sure that this is A over 2, positive x. I'll just get rid of that. No, I guess I'm not getting rid of that. Translate positive x, A over 2. Now we'll create our subsystem. You can just Control G, makes a subsystem. Make it big enough to see what's going on. Now we will call this bar 2. Now between the ground and bar 2 we have a revolute joint. This is joint O2 in our diagram. And then between this and bar 3 we have another revolute joint. This is joint A. Then we have another bar, which is composed of a solid. Control R just rotates it. And 2 rigid transformations. This is going to be our second bar, so it is going to be B, I think it was. Make it a different color. Blue and orange. Alright, make another subsystem. Connect this to there. Now, for bar, what is this one? Bar 3. Bar 3, we need another revolute joint. Now we need make another bar, which is made of a solid. 2 rigid transformations. So we ought to configure these. It's going to be C over 2. C over 2 here as well. Different color, make things easier to see when we break it. Alright, now I am actually going to flip this subsystem. This is going to be bar 4. Yep. Then we have here and here. There are two ways to do this. So we already know that we're going to have a revolute joint here. Now, two ways to do this. One, we could do it with a rigid transformation. Where we're going to translate in the positive x direction. I believe it is D. And the translation always goes from your base frame to your follower frame. So our follower frame is going to be however far D was from the world frame at O2. So that's one way to do it. We should be able to see if it worked. It appears that something is messed up. Let's go to our tools, model report. Well, it says that everything is good here. So let's see our frames. Something is going on with our orange bar, which is this one, I think. Yep. That's what's going on with it. B02. Alright. Now we should be good. Control D automatically does it for you. Still something wrong. Oh, maybe I didn't set up either of them. I did not. Probably should have looked at that while I was here. Alright, now that we have what appears to be a fully assembled model here, so another thing that we can do is to define state targets. So if you want to see this thing in a specific state, so for example in the lecture notes it has theta 2 is 40 degrees. So if I double click on my revolute joint, I can go state position target. I'm going to change it to low because if it can't make it exactly, it'll throw errors. So I'm going to say that this is 40 degrees. And then to get the right configuration, I'm going to say that theta 3 here, joint A, is 20.3 degrees. Now if we do this, we should get something similar to the picture, if the picture had these same lengths. Now to make it move, what is this? This is joint B. And this is 04. Now we are just going to move it rather simply. Because we're going to provide the input, it is going to automatically compute the torque. We need to tell it to do that. Hit apply. Now I'm going to just drive it with a ramp function, which I'm going to say is going to be, I don't know, 50. It's going to end up being degrees per second. It's going to use the derivatives and whatnot from here. And we need a Simulink to PS converter. Connect that to our Q here. Make our lines pretty. Now hit run. Not enough input derivatives. That is because I did not set up the converter here. It needs to know that the units are in degrees, and it's going to calculate the derivatives, second order filtering. So now I can run it. And if you want to run it the other way, you can just give it a negative slope. So another way to do this, instead of a rigid transformation here, if you don't like the blank space, what you can do is do a bar, which will just be standard bar setup. I'm actually going to steal this. This bar, I'm going to make it gray. It's going to be a length of D, thickness T. Being black is okay, it's the ground there. Rigid transformation. Subsystem. And then before I forget again, I need to set these up. It's going to be D over 2. D over 2. Now we have our ground link. So 2 ways to kind of do the same thing. And that's it for this video. The next tutorial will be about creating an offset slider crank mechanism. So hopefully you watch that one too. Good luck.